One of the things you need to do, is covered in this question 9, is perform operations on complex numbers. All answers must be in standard form. So standard form is a plus bi. So all of these answers need to be in this form, a plus bi. A is the real part, b is the real coefficient of I, the square root of -1. So in this first problem, 6 plus the square root of -25 is equal to 6 plus the square root of 25 I. Where you factor out the square root of -1, that's I. And so this is 6 plus 5I. 6 plus 5I. Okay. Next problem, standard form. All right, standard form, it's always the real part first and the imaginary part. When we look at that problem, 7I minus I squared. I squared is equal to -1. So it's minus -1. So we simplify subtracting -1, that's 1. So it's 7I minus -1 is plus 1. And then in standard form, that's 1 plus 7I. So 1 plus 7I. Now in this one, this third problem, we have a subtraction of two complex numbers. So let's perform the subtraction. 3 minus 4I minus 6 minus 7I. So this is 3 minus 4I, subtract 6, and subtract minus 7I. Of course, that's adding 7I. So we have 3 minus 6. That's the real part. And then plus -4 plus 7. Excuse my difficulty with this tablet. All right, so this is -3 is the real part. Plus -4 plus 7 is plus 3I. So that's our answer, -3 plus 3I. A conjugate. Now a conjugate is just simply changing this sign of the complex part. I'm just going to write that. That is just square root of 3 minus 2 square root of 3I. That's the conjugate. Now, multiplication. This is where there's a little bit more to do. This multiplication, notice, is a multiplication of conjugates. 10 minus 3i times 10 plus 3i. Let's just see what that comes out to be. I'm just going to, well, let's just do it. So 10, let's change color. 10 minus 3i times 10 plus 3i, 10 plus 3i. Multiply this like any pair of binomials. It's a FOIL process, if you will. We do 10 times 10, which is 100. 10 times 3i, which is 30i. Now, minus 3i times 10, which is minus 30i. And then finally, minus 3i times positive 3i, which is minus 9i squared. 9i squared, or I squared, is -1. So this is plus 9 out here. So we have 100 plus 9. And then because they're conjugates, the outside and inside products cancel each other out, and we're just left with a real number, 109. 109. Now there's a rule for when you multiply conjugates of complex numbers, and it's this, that if you have, let's use this area over here, that if you have a plus bi times a minus bi, conjugates, generic conjugate numbers, that the answer is just going to be a squared plus b squared. You can see that happening here. We have 10 squared, or 100, plus these cancel, and because of this I squared and the the last product, which is -1, and that last product is always going to be negative, that it really just comes out to be a squared plus b squared. So you can look at this and quickly say, well, 100, 10 squared, plus 3 squared, 9, is going to be 109. And that will help us quickly perform this division using the rule for division, where we multiply by a conjugate, a form of 1 that uses the conjugate of the denominator. So the last problem, looks like this. 15 divided by 2 minus I. To perform the multiplication, we're going to multiply by a form of 1, which is the conjugate of the denominator, 2 plus I over 2 plus I over 2 plus I. Now the denominator is going to be 2 squared plus 1 squared, or 2 squared is 4 plus 1. That's going to be 5 when we finish off. The numerator is 2 times 15, or 30, plus 15 times I, or 15i. And all of that is over, let's just call that 5. So the answer is going to be 5 into 30, or 6. 5 into 15 is 3i. So this is 6 plus 3i.